Hello everyone and welcome to our presentation. My name is Leila Aflatoony. I'm a faculty at Georgia Tech School of Industrial Design. I collaborated on this project with my colleague Susan Lee, an occupational therapist and a research scientist at Georgia Tech. The title of our presentation is AT Makers, a multidisciplinary approach to co-designing assistive technologies by co-optimizing expert knowledge. Giving a little bit of introduction, assistive technology improves the functional abilities of individuals with disabilities and enables them to perform activities of daily living independently. However, many off-the-shelf assistive technologies often do not properly address the unique issues arising from physical impairments. In this study, co-design approach has been applied to address problems for which there is no feasible market solution due to the nature of the need, or for which existing solutions are less than satisfactory due to misfit with the specific needs, abilities, and context of the users. The importance of increasing collaboration between designers and people with a physical impairment or disability in the creation of design solutions is well recognized. However, while some studies have reported methods to engage people with disabilities in the co-design process, most work to date has focused on the two-way interaction between designers and people with disabilities. So there is a lack of knowledge about situations in which the design problem requires expertise beyond that possessed by the designer and necessitates collaboration with another profession such as occupational therapists. So we investigated the benefit of OT, industrial designer, and user collaboration by studying their knowledge exchange processes. As occupational therapists and industrial designers are two types of professionals who are well poised for collaboration. Occupational therapists champion principles of client-centered intervention to identify tailored solutions that support individuals with disabilities to maximize their independence in daily activities and participation in society. Assistive technologies are an important aspect of their toolbox. Many OTs adapt everyday tools and existing assistive technologies to ensure the best fit with their client. On the other hand, industrial designers similarly embrace human-centered approaches and bring tangible skill sets in ideation, prototyping, CAD modeling, 3D printing, and manufacturing to support realization of AT design. 4 participatory workshops were held to study occupational therapists, industrial designers, and user collaboration in developing assistive writing devices that would reduce or eliminate the user's pain. This was a goal identified by the user herself from a prior research study she participated in. We employed an observational approach to collect and analyze data on participants' exchange of knowledge, as well as their collaborative construction during the co-design processes. In addition to structured observation, we conducted 2 focus groups, one for occupational therapists and one for industrial designers, and a semi-structured interview with the end user at the conclusion of the workshop series. To elicit opinions on the quality of the workshops and perspectives regarding the co-design assistive technology processes in interdisciplinary teams. The findings of the study revealed that occupational therapists, industrial designers, and the end user perceived the participatory workshop to be beneficial as they contributed to amplifying and optimizing their skills, knowledge, and expertise. Our observation revealed that parts of their co-design approach were concentrated on supporting and optimizing each other's tasks and activities, in addition to gaining new knowledge. For example, while occupational therapists were describing their insights regarding a potential AT design direction, The designers help to give a tangible structure to the conversation through sketching activities. Throughout the workshop, we observed an ongoing exchange of skills and consideration of AT solutions. For industrial designers, the ability to leverage occupational therapists' clinical expertise was perceived as extremely beneficial, as it gave them more confidence that they were starting the design process with a set of robust, sophisticated design requirements. For example, during the fourth workshop, Occupational Therapist 1 used an anatomical chart depicting the muscles and nerves of the hand to educate an industrial designer who incorporated knowledge in the development of assistive technology designs. For occupational therapists, the co-design workshop presented them with the opportunity to gain exposure to tools typically used by designers, such as thermoplastic. Additionally, designers were exposed to clinical aspects of assistive technology prototyping, such as sanitary conditions for assistive technologies, and considered them in assistive technology design. Also, we found that being exposed to the interdisciplinary team of experts not only resulted in co-optimization of the participants' skills and knowledge, but also led to the co-creation of novel assistive technology solutions. For example, OT4 proposed a device which was inspired by a computer mouse to enable the end user to write without the need to hold a pen. The idea of a computer mouse was articulated by OT4, but evolved through the co-design process as Industrial Designer 1 worked on expanding these features by providing options for using multiple utensils with the same device based on the user's suggestions. Okay, our first takeaway speaks to the need for three-way collaborations because complex design problems require more knowledge than any single person possessed. We uncovered how cross-pollination of clinical, design, and personal expertise amplified the cohort's collaborative skills and knowledge. Also, we argued that the co-optimization of experts' knowledge results in the creation of useful novel AT solutions. Each participant had distinct sets of skill and expertise informed by the training and prior experiences that influenced their approaches, and the co-design workshops provided them with the opportunity to be exposed to the expertise of others. This is in line with the notion of mutual learning, a central value in participatory design, as a means to motivate and empower participants. Future studies are needed to investigate the co-creation of assistive technologies in clinical setting, as well as clinical making spaces to support such collaboration. This is the end of AT Maker presentation, a multidisciplinary approach to co-designing assistive technologies by co-optimizing expert knowledge. I would like to take this opportunity to thank all our participants for their support and participation in this research, and thank you for your attention.